Hey everybody, Shawn here from theautomationschool.com, and in this episode of The Automation Show, we're going to answer a question that a reader asked a while back. What is the difference between FlexIO and PointIO? Now, I've already written a companion article to this video, which I published a couple weeks ago over at theautomationblog.com, but I figured it'd be cool to do an episode of The Automation Show so we can actually do a little show and tell. Now, before I get started, I want to say, we'll look at all the similarities between the two lines before we look at what the differences are. And I also want to point out we're not covering the Flex 5000 1769 or a 5069. Don't have any Flex 5000, so that's why we're not covering that. Would love to get a sample from Rockwell, but I also couldn't get from my local distributor adapters, Ethernet adapters, or any adapters for the 1769 or 5069. So, the reader's question was specific to PointIO and FlexIO, and while I would like to do a comparison with those others, we don't have all the equipment to do it, so we'll just cover PointIO and FlexIO today. Now, one of the reasons I'm doing this too is because I have to teach lessons on PointIO and FlexIO for my Control Logics course and my Compact Logics course. So I figured this would be a great way to get everything together. I go through and do this video, and then I can go on and do the lessons for those two courses as well. So with that said, let's go ahead and get started and talk about the similarities between PointIO and FlexIO. And we'll start by looking at the fact that they're both distributed I/O lines. And, there's no controller that Rockwell makes that will control up to 30 local FlexIO modules or PointIO modules, right? Like we have the Compact Logics where you can have 30 or 31, 1769 or 5069 modules locally if you get the bigger processors. But that's not the case with FlexIO and PointIO. Now, there used to be a Flex Logics that could do 2 strings of 8 modules. But that was unfortunately obsoleted many, many years ago. And so there's really no local controller for FlexIO. It has to be on distributed I/O. When it comes to PointIO, the only thing we can use it locally with is like a Compact Logics L1, like an L16 or L18. I think the most you can have is 8 local expansion modules. So a far cry from 30 modules. So for all intents and purposes, these two lines are designed to be distributed I/O, and they're not designed to be local I/O. With that said, one of the things, even though they look substantially different, right? One of the things you'll notice is that they both have what we call terminal bases, which the I/O modules plug into, okay? And they look very different, but, they both have keys on them. And depending on what that key's set for, will depend on, let me go ahead and zoom in here, will depend on which module will actually fit into the base. So that's one similarity, okay? And another similarity is that they both can mount on DIN rail, okay? So they're both designed to support DIN rail as well. With that, the last terminal module or terminal block in the series needs to be covered with a plastic cap just to protect the connections there. So that's the one for the FlexIO. And then the one for the PointIO, it's more of a slide-on cover here. Okay, I'll just slide that on like that. There you go. So that's also a similarity. And both these lines can be mounted either horizontally or vertically, okay? And that's important because a lot of times you'll want to mount it vertically if you're doing a retrofit and there's not a lot of space, right? So I know a lot of people have mounted FlexIO to actual supports or poles in their plants, which is really cool. So they both support that. Now, I think the only other line from Rockwell that supports that is the Flex 5000. Everything else has to be horizontal for the convection cooling. So keep that in mind. And what else do they have? They both support removal and insertion on the power. So keep in mind that this is not for hazardous locations, because when you remove them, if they're on the power and you remove the modules, you can get sparks. So definitely not a hazardous location option. But both lines, you can replace the module on the fly while the system is powered. And you'll see on the back of the modules, the pins are offset. The power pins are offsets to enable that. What else? Well, you can split racks of each of these lines with what we call a extension cable. This is kind of popular with the Flex-IO, not very popular with the Point-IO, because the Point-IO cables, you see how thin this cable is? The Point-IO cable also carries power, and so it's really thick, and doesn't have a great bend radius. And I know last time I know somebody who bought one of them, they just threw them away because they were so hard to work with. So while they both have extension cables, the one for the Point-IO just doesn't seem to be very practical for many applications. And finally, both lines today support DeviceNet. So here we can see the DeviceNet adapter for Point-IO and for Flex-IO. They both support ControlNet. Okay. This is only a single non-redundant adapter, where this is a redundant one. And Ethernet. And Ethernet's what most people are using today. They also both support Profibus DP. Okay. Now, a couple of notices here. I got two Ethernet adapters. This is a single port. This is a dual port. So this supports DLR and linear type daisy chain connections. It's a big difference between those two. And this is the newer Ethernet adapter for Flex-IO. I have an older one on the wall. It doesn't have the thumb wheel switches here for the node address for the last octet of the default subnet. And those you really need to use BootP to set up. The BootP utility to set their IP addresses up. But the newer ones do have that, which is a great addition. Now, one thing I don't have here is remote I/O. Love to get my hands on, especially the Flex-IO version. But Flex-IO was very popular on remote I/O. The old remote I/O for, well, typically a PLC5 SLC 500s, typically PLC5s. Was kind of painful to do the analog because you needed block transfers, but anybody who's done a lot of PLC5s, that's really not that difficult if you've written a lot of programs. Now, if you're troubleshooting PLC5s, that can confuse people. But on the SLC 500, that was kind of a beer for most of the SLC 500's life. So people, typically stayed away from that. Matter of fact, it was actually easier to use DeviceNet. I know a lot of people are cussing at me right now, but it was actually easier to use DeviceNet with analog on the SLC than it was to use remote I/O analog. But in any case, I do believe there initially was a remote I/O adapter for Point-IO when it first came out, and I think it was pulled off the market pretty quickly. I didn't have a chance to research that, but that's what my memory, this old man's memory is telling me. But in any case, so those are the common things between the two lines. So they have a lot in common, but they also have a lot of differences, right? Besides the physical shape, they're physically very different sizes, right? The first is, Point-IO cannot be panel mounted, right? If we look at the Flex-IO, yeah, you got a couple of mounting holes there, right? Nope, not going to happen with Point-IO. You're stuck with DIN rail, which is typically not a problem, right? Okay. The other thing is that Point-IO, because the maximum number of terminals, unique terminals you can have is 8. The biggest module, the most dense module you're going to have is 8. Now, if you see some of these other terminal blocks, here, let me get them up here. You'll see that they actually have 12 terminals, but there's only 8 unique ones there. 7 is tied to, I think, 11, and 8 is tied to 12, and so on. So the last 4 are just internally tied to the 5, 6, 7, 8. So you're not getting extra terminals there. And here's the problem with that, or not a problem, but a design challenge, right? Is that if you do get an 8-point, let's see, where's my 8-point module here? So if you do take an 8-point module, right? This is an 8-point input module, DC input module, then you're going to use all 8 terminals for your inputs. Well, what if you're using 3-wire devices, right? Where do you put the other 2 wires, right? So in that case, what you're going to need is you're going to need another terminal block with terminals on it to land those other 2 wires. Or you could buy, I think they're kind of expensive for what you get. You could buy a VTM and CTM, and these connect to the bus, the power bus, to either the voltage, common or voltage. Let me get that right. Red is voltage, blue is common. Okay, so that's the only way you can get your extra terminals. Now, that's not a problem with Flex-IO. If we look at something like a TB3, right? I got like 50 plus terminals there, right? And so I can land everything I want right on that terminal block, which is really cool. And there's no power bus. The only bus on this on the Flex-IO is the bus for the actual electronics, okay, the power for the actual modules themselves. Whereas with the point I/O, there's also the field power bus. Whoops, going to take the cover off here. Okay, so we also have a second, we have power for the electronics and the modules, but we also have field power bus. So that's another thing. If you needed to, start with DC and then go to AC, with FlexIO, it's not a problem because every base is isolated, right? Well, with point I/O, because they have this common power bus going through all the terminal blocks, you would need to isolate that. You would need something. Where is it? Oh, here it is. You would need something like an FPD. Okay. So in this scenario, I'm using all DC. And then I wanted to use AC on this relay, so I have to put in FPD as this is a field power distribution block. It breaks. You can see there. There's no power there, right? It's not even accepting the power pins from the left-hand side, right? Because it's breaking the power of the field bus and allowing you to bring in this case, maybe AC, to go out to the modules on the right. So that is used either to isolate. Sometimes you want to isolate your digital I/O from your analog, so you put one in there. Or you definitely need to isolate the power bus from DC to AC because of different voltages, right? So in any case, that's something different with the point I/O that you didn't need with the FlexIO. And while we're talking about that, FlexIO only supports 8 modules in a string. Now you can use that expansion cable to break that string into 2. So I could have 4 and 4 or 6 and 2, but that's it. Every adapter, every network adapter for the FlexIO can only handle 8 modules. Now those modules are higher density than the point I/O, right? So we were talking about the 8 point being the highest density I could have. Well, very common in FlexIO to have 16 point. So you may only have 8 modules, but you're getting 16 modules worth of inputs, into a system, versus a point I/O. So, but on the flip side, the point I/O can have many more modules. Instead of being limited to 8, it's limited to 63. Now, this is very dependent on what you're connecting it to, okay? And you can use the Ethernet IP capacity tool that's in IAB to figure that out. That'll also help you with any of the other modules you may need in your system. But in any case, I can have 63 modules, theoretically, in a system. However, this little bus here for the power for the modules, it's not big enough to handle the power for 63 I/O cards. So that enters in another part that we need, and that is called the EP24DC. What this allows me to do is add more module power to the backplane. So it breaks the power bus. It also supplements the module power so that you can provide more power to your modules. Because depending on which modules, typically it's 12 or 13 modules, and then you'll need one of these EP24DCs. But some modules draw a lot more current. So again, probably best to use IAB. We have a video on that on the channel here and an article over at the automation blog on it. But as well as using the new Ethernet IP configuration tool that's inside of IAB now. We also have an article on that over at the blog. But the IAB will put these in automatically for you. But again, with standard digital input and outputs, you're looking at, typically 12 or 13. But once you start adding like thermocouple modules or any high current draw module, it could be a lot less. So keep that in mind. So yeah, point I/O can support up to 63, depending on device, 63 modules per drop. But you have to take into account this FPDs and the EP24DC. So it's not as simple as when everything was isolated with the FlexIO and every terminal base was its own island, unless you daisy chain them together, which a lot of people did if they were the same voltage. But in any case, so that's a huge difference between the two. Another thing that I want to point out here is that point I/O offers safety I/O, okay? Using the default Ethernet adapter, you don't need a safety adapter. You can get safety I/O with your point I/O. As far as I know, that's not available for FlexIO. It is, I believe, available for Flex 5000. Again, we don't have any here. But I don't think it's available for Flex IO. I absolutely don't. So that's another huge difference. And probably the last thing I want to talk about here is last state. I was unfortunate enough to be on site when a customer discovered that point IO does not always hold last state. Now, you're asking, why would you want your IO to hold last state when it loses connection with the controller that's controlling it? Well, let's say that IO turns on fans, and those fans pull out dangerous, hazardous gases, right? That could, or pump out hazardous liquid, right? Well, if the connection between the PLC and the IO gets disconnected, you want that to keep doing what it's doing. It's doing a very important job. It's pulling out dangerous gas or liquid from an environment that could be harmful to people, right? So we don't want it just to stop because the connection to the PLC get disconnected. If those fans or pumps are on, we want them to stay on, right? So not all of Rockless IO will honor that last state setting when a user downloads to the controller. And it kind of baffles me. I don't understand why this is. I don't know if it has anything to do with the device net bus that really makes up the backplane of the point IO. But you can find there's a tech note over at Rockwell that covers all this. But I've seen it firsthand with point IO. If you're doing a redundancy system, especially, because a lot of times with redundancy, right? That's why you have two controllers. You can update one while the other one controls the system. But here's the thing. Typically, you're not going to use point IO in redundancy systems because typically in redundancy systems, last state is important. So keep that in mind. The difference between point IO and Flex IO with last state is that point IO will not hold their last state if the user downloads a new program to the controller, whereas Flex IO will, okay? And in that tech note that on Rockwell's knowledge base, I think it's locked behind a paywall, but in that tech note, they cover all the other different IO families and how they react. But in any case, just know that point IO, if you download to the controller, will not hold last state. It will go off. Okay, that is not an issue with Flex IO. So that's an important thing, not for most applications, but for some mission critical applications, it's something you really need to know. And I'll even put a link to the tech note in the description of this in the show notes for this episode. So if you're interested in that, you can find out about that. Now that we've covered how they're the same and how they're different, let's look at the comments. Again, I wrote this article a few weeks ago and published it on theautomationblog.com. And I pulled out 3 of the comments I wanted to share with you. Joseph E2 writes that he likes the products, but he wants to point out that with analog modules, because ControlLogix, by default, ladder logic does not have a scaling instruction. Don't know why. For years, you've been able to download a free AOI to add that to. But whereas in the Micro 800, they're always adding instructions. Apparently, they don't want to add instructions to ControlLogix ladder logic. So you have no scaling instructions. Why is this important? Well, unlike the point IO, which does allow you to scale the analog, this is all per Joseph. I haven't tried this yet, but it sounds right. That these analog modules allow you to do scaling on board. Apparently, and I believe this is true, the Flex IO modules will not. So if you're using ControlLogix or CompactLogix and you're doing distributed IO, keep in mind that you're going to either have to add a scaling instruction or do it the old-fashioned way, but you won't be doing the scaling on board the modules per Joseph. The next comment we had was James Online. He says he really, really loved using the old Flex IOs back in the day because you could land everything right there. If you had 3-wire sensors, you could line everything right there. It was great. Now he uses mostly M12s, quick disconnects, so he doesn't have to, strip and wire, 45 plus different wires for each sensor. But he liked that, and I liked it too. I mean, in most cases, you didn't even need an opposing terminal block because this looks just like a terminal block, right? That said, he does wish that there was some way to isolate the power on the point IO without needing the FPD. It would be nice if there was a terminal block that maybe passed power on to the next module, but allowed you to bring in field power to the terminal block just for this IO card. And That's actually, I believe, an option you'll see with the 5069, but he thinks that would be really cool if they could add that to Point.io. So I don't know if they will. It would be nice if they did, but in any case. And then the last comment I want to highlight is from ILBob, or ILBob. He likes them both, but what he really liked, we talked about the common module and the voltage module. He would really like a ground module as well. So this connects to the common, this connects to the voltage pins, right? He wants one that connects to the ground so he can land his shields from his 3-wire devices, his 3-wire sensors. And that makes a lot of sense to me as well. I mean, it'd be nice to ground those right on some type of module, right? Instead of having to run those to a different terminal block. So all great comments. I want to thank all the guys, everybody who commented on the post. If you have new comments, and instead of trying to keep up with everybody on LinkedIn, YouTube, Facebook, Twitter, email, and just blogs and all types of social media, I ask everybody just to post your comments over at the Automation Forums, which recently moved, if you saw my last video, to forums.theautomationblog.com. And that's where I go. I try to go there every work day to answer questions. I just advise people when you ask a question, put as much information in as you can, because a lot of times people will just post, hey, this doesn't work. And it's like, well, what version are you using? Or an operating system are you using? Et cetera, et cetera, et cetera. What's the part number of your controller? So help me help you if you have a question, or somebody has a question. But that's where I answer free questions, for people who aren't, enrolled in my courses or have questions that are not part of the course, like, if somebody's taking my control odds course and he has a Slick 500 question, that's where I send everybody. So I try to get up there at least once every day, every work day, to answer questions. And it's tied right into the Automation blog. So if you comment on this post at the Automation blog or the previous post, the comments go right underneath it. And I think it works out pretty great. So, and plus you can share files and pictures and all that stuff where you can't do that on the blog, but you can do that in a forum. So in any case, we're even looking at upgrading the forum. But with that, that's my comparison of Point.io and Flex.io. Love to hear your thoughts. And with that, I just want to wish everybody a great week. And until next time, my friends, peace.